In this video, we're going to learn about rotations in plane space. So before we get started, go ahead and grab your protractor and compass so that you have those for the video. So if you don't have them, grab them and then we'll get started. So when we talk about rotations, just remember rotations are a rigid motion, which means that the shape and the size of the object being rotated will remain the same. And what it's going to do is it's going to turn a figure. So rotating means you're turning a figure. And when you turn a figure, you're always going to be turning it around what we call the center of rotation. So that center is going to be a fixed point, meaning it's going to get like locked in place. It's going to stay in place. So that is called the center of rotation. And then when we talk about rotation, recall direct isometry. So this deals with the order of the letters. So the orientation is preserved. That's when we say direct. And then being an isometry means the length is going to stay the same. Same with the angle measures, those will stay the same. So the figures in the end will be exactly the same shape and size. And then this next idea here is that not all points are going to travel the same distance under a rotation. So when we do a translation, all the points move using that translation. When we did reflections, that distance changes depending on how far the pre-image is away from the line of reflection. This is going to kind of use that same idea. So we're going to look at each individual pre-image point, and we have to keep the distance from the center of that pre-image point the same to get to the image, but not all pre-image points are going to use that same distance. So that's what this is saying, that not all points use the same distance, but each set of pre-image to its corresponding image points will use the same distance. And then remaining invariant here, so any points that are on the center, so points that are on the center of rotation will remain invariant. And remember, invariant means remains the same. So that means that they're not going to move. And we're going to see that in a minute here, where if the center of rotation is a point that you're trying to rotate, well, that center is just going to stay right in place, and it's not going to move. So there's two ideas that we're going to talk about, and we're actually not going to look at how to rotate an object. We're always going to be given a situation where you have the rotation in front of you, and you're going to have to find the angle of rotation or the center of rotation, but you're not actually going to have to perform the rotation yet. We're going to look at that on a coordinate plane to be able to do those rotations. So for this, we're really just looking at the properties of a rotation so that you're getting ready to do rotations on a coordinate plane. So that's kind of where we're heading with this. So to determine the angle of rotation, what we're going to do is we're going to look at the angle that's formed between the pre-image point, the center of rotation, and the image point. So for example, if I look at point A, so point A is right here, the center of rotation is going to be point D, and that would be given to you in most situations. In this situation, I know that it's point D because point D doesn't get mapped anywhere. It stays in place, so that tells me that this is actually the center of rotation. And a lot of times, like I said, that'll be given to you right in the problem. So then, let me just move this over. So then A, using the center, so from A to the center of rotation to A prime, we have an angle that's formed. So that angle that's formed, so let me go ahead and just kind of highlight over that. The angle that's formed right here is considered the angle of rotation. So we're going from A to A prime, which means we're going in a clockwise direction, clockwise. So I'm just going to write that. Remember, clockwise goes the direction of the clock versus counterclockwise is going the opposite direction. So this is going clockwise, the direction of the clock. I want to find that angle measure. So what I'm going to do, I'm going to take my protractor, and there's really two ways that you can do this, but the center of your protractor needs to go on the vertex of the angle. And then what you can do is you can line up the flat edge on this segment right here. And then if you're doing that, then you're going to use the inner numbers. So from 0 to, it looks like about 80 degrees. Maybe it's more like 79-ish. But I'm going to go ahead and just go with 80. So just kind of approximating that. It looks like it's close to being 80 degrees. So from 0 to the 80. And so that's one way. The other way was I could turn this and then I would be using the outside numbers. So see how now if I have this edge, I'd be using starting at 0 going up. And again, you see it's close to 80. It's probably more like 78, 79. But for the sake of this, I know my tracing wasn't perfect. I'm going to go with 80 for it, just kind of rounding it up to the nearest whole number. So I'm going to go ahead and label that as 80 degrees. So that right there is the angle of rotation. And point D, remember, stayed in place there. So that's how I knew that that was the center. So if I kind of answer some of these questions, measure angle A, D prime, A prime. Well, we got that. That's 80 degrees. What happened to point D? So point D, I'm just going to answer that, remains invariant. Because it's the center of rotation. And then it says, can you see that D is the center? Well, yes, it is, because it stays in place. So every point is coming from D. See how everything from D is the same distance away? So you might not be able to verify that right now, but you can kind of eyeball that and see that A to the center is the same thing as A prime from the center. So that's an important idea. And then the next part here says draw angle B, D prime, B prime. So let's go ahead and do those in a different color. So from B to D to B prime. So this actually we're referring to as D prime in the problem here. It doesn't really matter. D or D prime, it stays the same. So whatever you want to call it. So now if I want to go ahead and measure that angle, so let me move this over. This thing is going to shrink a little here so that I can actually measure. So I'm going to take, and remember, if you need, so your protractor, you can't shrink and expand. So what you're going to do is just extend that line out so that you can make sure that when you're on the bottom edge here, you need to make sure that line's lined up. And then over here, you might not be able to see through your protractor, so you might not be able to see that line. So what you can always do is just extend your segments out so that you can see the little hash marks on here. Okay, so if you need to, extend those out. So anyways, I go from the center, so starting at 0, again, I see that it's about 80. Again, I'm approximating, but I'm seeing 80 degrees. And again, clockwise rotation because I'm going from B to B prime in a clockwise rotation. So let me erase that. So let me just I just want to write this a little bit neater so you can actually see it. So this is 80 degrees. So we see that they're the same. And then if we were to do the last angle here from C to D prime to C prime, again, you're going to see that it's the same. So I'm going to just make a note here. You can actually try that if you don't believe it, but it will end up being the same. So I'm going to say that the angle of rotation remains the same. So when you're doing these rotations, the angle of rotation will always stay the same every time you're doing it. Now remember what I said, that distance, each point from the center of rotation is different. The distance from A to the center is going to be the same distance to A prime, but the distance from B to the center is a different distance, but the same distance to get to B prime. So the angle of rotation, though, is always going to be 80 degrees. So that's important to make note of. And then the last thing here is if we had to find the center. So when I looked at this first example, I knew that the center was at D or D prime because that point remained invariant. But when I look at this example, I don't know where the center is. So if you kind of think about what I just said, in this example, that center is equidistant from A and from A prime. It's the same distance. It's also the same distance from B as it is from B prime, so it's equidistant from those. It's also equidistant from C and C prime. So if you think about, you want to find the point that is equidistant from two given points. Essentially what you're doing is finding the perpendicular bisector. Anytime you want to find the set of points equidistant from two given points, you do the perpendicular bisector. And then where the perpendicular bisectors cross is going to be the center. So we're going to do the perpendicular bisector of two sets of coordinates. So let's do it and then we will write it out. So what I'm going to do is I'm going to look at B and B prime. So I'm going to go ahead and connect those. So those are the pre-image and image. And I'm going to do the perpendicular bisector construction because I need to be equidistant from both of those points at the same time. That's how we're going to get this center. So it's almost like when you construct the line of reflection, you do the perpendicular bisectors. But in this case, we're doing the perpendicular bisector not to get the line, but we're doing it to get all points equidistant from those two given points. So what that means is if I were to connect these, I'm going to use a dotted line just to, because in the end, we're going to look at the intersection. So if I go ahead and connect these, and this dotted line represents all points equidistant from B and B prime. Now if I repeat this for A and A prime, and remember this is a rotation that occurred between these, not a reflection. So A and B prime, that would be if you were reflecting, those would actually be the points that match, but in this case we're turning, so that's why A ends up over here with A prime. So now I can go ahead and do my perpendicular bisector. And then from here, go ahead and connect those. So drawing in my, I'll just make it dotted again. And now what you're seeing is this is the set of, the blue line represents the set of all points equidistant from A and A prime. The black line represents a set of points equidistant from B and B prime. So if I want to know where I'm equidistant from both of those sets of points at all times, it's going to be at the intersection between them. So this point right here is the center of rotation. And you could connect more points if you wanted to, but I don't need to because in the end, my intersection will always be where two perpendicular bisectors cross, or if you draw in a third perpendicular bisector, it's going to cross in the same spot. So it's where the perpendicular bisectors cross, but you only need two of them. So the center of rotation is right there, which then means now that I know the center, I could find the angle of rotation. So the angle of rotation, if you take your center and you connect to, let's say we use A prime and A, this is going to be my angle of rotation. So in this case, here's my, it's going from A to the center to A prime. We're going in a counterclockwise direction this time. And I could measure that. It doesn't ask me to, so I'm not going to worry about it, but you could measure it and then figure out the angle of rotation as well. So this red represents the angle, the point represents the center. So to find the center of rotation, I'm just going to make a note here. You're going to construct the perpendicular bisectors of 2 or more, because remember you could do more, pre-image and image points. And that's it. And then, like I said, you have your angle. You might want to highlight it or something and label it that this is the angle of rotation. So you have the center, and you also can find the angle from here. So go ahead and try the check your understanding page. It's the same idea. So just make sure you can get these constructions down, and then we're going to do more with understanding these properties and how they relate to the coordinate plane.